Hello everyone, welcome back to another video. So today we'll discuss editorial for weekly contest 398 and I solved all four problems. I have a pretty decent rank today. I got 99 rank in global users except China, and I solved all four problems. Uh, Fourth problem is interesting. I would say it is a computronics problem. But first we'll see first three problems. So let's start with first problem. An array is considered special if every pair of its adjacent elements contains two numbers with different parity, and we have to return true if the given array is special, and else if false if it is not. Now parity means just mod of the number with 2. So for example, here in this case 2 1 4 adjacent elements 2 1 have different parity because 2 mod 2 is 0 and 1 mod 2 is 1. Similarly 1 4 adjacent elements have different parity because 1 mod 2 is 1 and 4 mod 2 is 0. In this case answer is false because 3 and 1 have same parity because 3 mod 2 is 1 and 1 mod 2 is also 1. So I don't think there is any logical here to explain. I'll just show you the code. And what I'm doing is I'm iterating from 1 to a dot size, and I'm just checking if a of I mod 2, if it is equal to a of I minus 1 mod 2, I will just return false, and finally return true if none of the any of this index satisfies this condition, and just return true at the end. So this was first question, as usual, implementation based. Now move to second question. This I think it's an interesting question. I also thought I also took some time here. As you can see, I solved first in 1 minute, but second in 7 minutes, but third in 4 minutes. So B was difficult for me than C if you consider the time taken for both of them. So in this question, same concept is used of array special if pair of adjacent elements are of two different parities, and what we are given is we are given some queries, and queries of I is the start index and end index of a subarray, and we have to check if that subarray is special or not, and we have to return an boolean vector such that answer of I is true if the query's ith query subarray is special, and if it is false it should be false if ith query subarray is not special. And now if you see this first query is 0 to 4 all the elements, but if you see the whole subarray, the 2 and 6, the index 3 and 4 both have same parity. That's why here answer is false. First query is false and there is only single query. And in second test case 4 3 1 6, 0 to 2, this subarray 4 3 1, 3 and 1 have both are odd. That's why first answer of first boolean in the vector is false. And for second query 2 3, this is 1 6 subarray and both of them have different parity, so here answer is true. Now for this obvious reasons, queries are 10 raised to power 5, so n square kind of solution would not work, so basically we have to use a prefix sum. Now what kind of prefix sum? Let's say I have an array 1 2 6. Now I will convert this array into B. Let's say B can be a 0 1 array. Now what B represents? It represents that the parity, if the parity of current element and its previous element are unequal or not. So what I will just fill, for 4 its previous element is 3 and parity of both of them is not equal, that's why I will fill b with 0. Similarly, for 1, parity of its previous element and 1 is not equal, so again 1. For 2 and 1, again 1. For 2 and 6, parity of both elements is same, so I will fill 0. And for first element I can fill anything 0 or 1 because they don't have previous element. And in prefix sum eventually there will the contribution of this will similar for all cases, and we will never access this first element in prefix and b array. I will explain that in a later explanation. After b, I will calculate prefix sum of this. So this will come out to be 2, 3, then 4, and then 4 here. Now let's say I have to check for subarray 4, 1, 2 if it is an special array or not. First we will compare b with it. B was like this. Now in this subarray, this first element's b value is not relevant to us because it is about its parity inequality with its previous element, which is not in the subarray. So subarray's first element's b value is not required. What required is if all other indexes in the subarray except the starting element, if all of them are 1, that means my whole subarray is a special subarray. Now how to check that all of them are 1? To check that, we can just simply check prefix sum of the subarray. That means if I have all the elements in the subarray equal to 1, then the prefix sum of subarray should be equal to length of subarray. So to check all of them are 1, what I will do is I will calculate prefix sum till this and subtract prefix sum till this. Then I will get a prefix sum of this part. So all the elements except first element of subarray, and if it is equal to r minus l itself, then I will just return I will just add true to my answer, else I will add false to my boolean vector. I hope you understand this. This is I would say not intuitive concept. This doesn't come to mind when you are trying to solve a prefix sum problem. You will just think of just a simple prefix sum of standard prefix sum, but you have to convert this information into some other array and take that prefix sum. So this was not intuitive, I would say, but easy for implementing. So let's just see the code. So first of all, what I did is I've created a prefix sum and prefix array. Pf of 0 can be 1. Now this can never be accessed because let's say I'm querying from 0 to n. I will only need prefix sum of 1 to n because 0 is irrelevant, as we have discussed that first element of subarray is not necessary because its information is with its previous element, which is not present in subarray. So this, how much this 0th element contributes in prefix sum doesn't matter. That's why you can keep it 0, you can keep it 1e9, whatever you want, but if you put it 1e9 there will be integer overflow. So you understand what I'm trying to say. This will not matter any in the contribution of whole prefix sum because it will always get subtracted. Now what I'm doing is I'm setting pref of I if parity of its element and its previous element are unequal. I'm setting it to 1, else I'm setting it to 0. And instead of creating b and pf separately, I'm just creating pf and updating pf of I with pf of I minus 1 at every step. Now I am iterating over queries vector getting L and R. If R and L are equal, that means our answer is true, because size of array 1 is always a special array because there are no adjacent elements. And else what I'm doing is I'm calculating prefix sum of the subarray using prefix array, and I'm checking if it is equal to length of subarray except first element, so that will be R minus L, and if it is equal to D, I will push back true, else I will push back false. And this was second question. I think, yeah, there are quite a lot of submissions for this, but I found this not difficult but interesting problem, I would say. So let's move to third problem. This is also easy question, but you have to just think digit wise. So in this question we are given an positive integers where all integers have same number of digits, and digit difference between two integers is count of digits that are in same position in two integers. So, and we have to find sum of digit differences of all pairs of nums. So in first case we are given nums array as 13, 23 and 12. Now digit sum is here is 4 because the digit difference between for this 1 and 2 is 1, that's why 1 it is contributing 1. Similarly this 3 and 2 is contributing 1 again, and this 2, 3 and 1, 2 is contributing 2, and total answer is 4. Similarly in this case all digits are same, so answer here will be 0. Now in this question key idea is to represent all the numbers to understand the solution digit wise. Let's consider that all the elements in the array are of size the number of digits in it is 1 itself. So this is my array, single digit numbers are there. Now for this 3, what are my possible combinations? This 1, this 2, this 4. So basically all the integers which are different from 3 itself. So can I represent them like this? Total number of integers is 6 minus frequency of 3. Now here 6 is 6 itself, and 6 is size of array, and 3 is frequency of 3, so 6 minus 3. So answer for this 0th index is 3. Similarly for first index it will be 3, for second index it will be 5, for third index it will be again 5, and fourth index is 3, so 3 again, and for fifth index it will be 5. Now what this is contribution of 0 with all other element, contribution of element at 0th position with all other elements. Similarly 3 for first index is contribution of element at first index to all other elements. So this first for 0th index, this 3 can be paired up with 1, 2, 4. Now for while counting contribution of this one, we also counted this contribution which was already calculated by 3, 1. So calculating twice is we are calculating it twice. So after this total sum whatever we take, so 3 plus 3 plus 3 is 9, and 9 plus 15 is 24 and 24 by 2, 12 is the answer for this type of arrangement. Now this is the case when we were having all of them as single digit numbers. Now what if we have two digit numbers, let's say 43. Now in this case we can just separate them with single digit. So this is the 10th digit and this is the unit digit, and we can find answer for this array, and take sum of both the arrays. Now this was key idea, to find answer digit wise, and for each digit find contribution of that digit. And for finding contribution, this was the whole idea, where first I'm finding contribution of ith index for 3, and the formula will be size of array minus frequency of that element. So all the other elements are contributing to that selected element. And this is a very repetitive concept of finding a pair such that digits are not equal. That will be just n minus frequency of that element. And finally just divide by 2 for bidirectional contribution. So 3 is contributing to 1, but 1 is also contributing to 3, so we are calculating it twice. So at the end, division by 2 is important. And that's it. This was the solution. Now let's see the code for this. So first I'm storing digits. I have created a 2D vector of 11 into 11, and what digit this is. So first vector is storing for all the unit places what is frequency of all numbers, and numbers can be from 0 to 9 itself. So what I'm doing is I'm iterating over n, and I'm just taking d as ai and started the counter. Now while d is greater than 0, I'm just taking mod, so last digit of the current element, dividing d by d equal to d by 10. This is basic finding digits of a number implementation. Now first rightmost digit will be unit place. That's why I'm digit of cnt, which is 0, and x I'm incrementing. So at 0th position, unit place, the frequency of x is increased. And now I'm moving to left, I'm incrementing counter again. So why this? I got a 2D map of 2D vector of frequency of all elements from 0 to 9 in each place, unit place, 10th place, 100th place, like that. And then I have declared an answer variable, and now I'm iterating over all those places, unit place, 10th place. And first what I'm doing is I'm calculating total sum. Then again I'm iterating over all the frequency of all numbers from 0 to 9. I just took 10 for buffer. Then I'm basically calculating this value. This value will be 6 minus what I can say is this value will be 6 minus frequency of 3. So total sum minus frequency of that element, and I'm just adding that contribution. So for each occurrence of 3, the sum will be same, right? 3 3 3. So I'm just adding that sum times the occurrence of that digit in ith place, and just updating sum at every time, every position, and finally returning answer by 2. So this was second question. I think I'm just checking if the rank list is updated or not. And if you see, this was also solved by a lot of participants. I think okay, it might be there might be some easier solution, I don't know, but I came up with this solution and this was pretty simple, I would say. Now fourth problem. This problem is, I don't know how this many people are solving this, but there might be a simpler solution, but I wrote on combinatorics type of solution. So let me explain the question first. So we are given a non-negative integer k, and there exists a staircase with infinite number of stairs, with lowest stairs numbered at 0. Now Alice had a jump with initial value 0. Jump is a variable. Now she is starting from stair 1 and wants to reach stair k using any number of operations. So we have to find the operation she can perform. Is there are two types of operations. First is go down 2 stair. So that is, if I am at ith stair, I will go to I minus 1, and this operation cannot be used consecutively, or if Alice is at stair 0, she can't go into negative stairs. And second type of operation is go up to stair I plus 2 raised to power jump. So jump 2 raised to power jump times skip 2 raised to power jump stairs basically, and after performing this, jump should be incremented, and initially jump value is 0. Now we have to find number of ways such that Alice can reach stair k. For example, if k is 0, so currently Alice is at first position. There are two possible ways to reach 0. One can be just move down to stair 0, and second can be use first type of operation. So go down to stair 0, then jump by 1 stair, that is 2 raised to power 0. So we will go to stair 1 again, and just again using first type of operation go down to 0. Now if you see, you cannot use this twice consecutively also, so you have to remember that condition also. And similarly for k equal to 1, there are 4 possible options which are written over here. So let's try to find observations here. First of all, the jump variable. Now if I do only one jump, let's say, so the addition of stairs would be 2 raised to power 0, because there is only one jump, which is 2 raised to power 0 first. If I do 2 jumps, the addition would be 2 raised to power 0 plus 2 raised to power 1. So similarly, if there are k jumps, some would the addition in current stairs would be up to 2 raised to power k, which I can represent as 2 raised to power k plus 1 minus 1. So this is first observation, that jump is always increasing consecutively, so number of additions will be always consecutive powers of 2. Now second is the subtractions, or the jumping down is just subtraction of 1. Now this cannot be done consecutively and also cannot be done go into negative. So if I have to represent a value k from 1, let's say I do j number of jumps. So first of all, I will do 2 to the power 0 jumps, then I will do 2 to the power 1 jumps, then I will do, let's say, 2 to the power 2 jumps. This will continue up to 2 to the power j jumps, and final output we should reach should be k, right? Now where can I insert -1 in this case? I can insert them either here or between this or between any of two additions of powers of 2. So basically if there are I cannot insert here because this is the first operation which is given by I'm at the Alice is starting from first stair, so this before this we cannot do that. After that we can do it, and after this also I can take an -1 jump. So basically if there I'm adding j powers of 2, I have j plus 1 gaps in which I can fit let's say required number of -1s, because I can calculate required by just fixing j. Now to fill j plus 1 gaps in required, the formula is just basically NCR, right? j plus 1 c required. So we have to fill required number of elements in j plus 1 gaps. So this was the core idea, I would say. So I will fix the here kth value is 10 raised to power 9, so maximum value j can have is 32, because if we go above that -1, if we subtract -1 we cannot go back again, it will just keep increasing. So filling these gaps is most important, and how to fill them. So let's just see the code. This requires, I don't know why, I think they should have mentioned mod, but I don't know if it is required or not. But let's say if I reach at position 31 and I have to calculate 31c2. So first I have to calculate 31 factorial, which is I think cannot be stored in integer because it is around 10 raised to power 30 something. But I think taking mod is enough in that if in that case. So I took mod with 1e9 plus 7 as usual. Inversion and modular multiplication declared two functions. These are standard template functions which I used, and declared an NCR and first pre-computed factorials with mod, and NCR formula is this: if n is less than r, return 0, and this is just NCR formula, that is n factorial by r factorial into n minus r factorial. And after this I'm fixing j. J means how many powers I am adding, so that power with this is how many additions I am doing. If I am doing 0 additions, that means jth value is basically -1, so I am not even adding anything. In that case my d value, that is total positive achieved, will be 1ll left shift I. So for 0 it will be 1, because I also need to consider this additional 1 because she is starting at stair 1. So for I equal to 1 it should be 1 LLI minus 1, but considering the first, she is starting at one element, that one is getting erased because of additional one. And if it is d, if d is less than n, I cannot achieve that value, and I have declared it replaced k with n because I thought long would be more beneficial to consider. And then I'm calculating remaining elements as d minus n, and gaps would be I plus 1. I have to fill those gaps with this remaining elements, and fact is just factorial vector, and finally returning answer. Now in this question there was no need of taking mod, means considering this condition of 31C2, I don't think this would come in this question, or it might come, but I couldn't find such case, or I just assumed that they didn't write 1d9 plus 7 in this question, because if you think of all possible combinations, they might go to 1d9 plus 7, they might go above integer. So it is kind of guesswork, I would say, but this logic is correct, but taking mod, I just did a guesswork and finally submitted, and it got AC. So I don't know what type of question is this, but I will, after this after contest ends, I will check other solutions and try. If they have written some different solution, I will check it. I think this can also be done with a recursive DP, I would say, but I don't know. I didn't think that through. I just wrote the solution which came to my mind first, and then made changes according to that mod and everything. So yeah, that's it from my side. I think my rank is pretty good. Last two contests were not so good on Leetcode for me, but this one was pretty good, I would say. So yeah, that's it from my side, and thank you for watching.